Hi guys, today's lesson is on force and work. It's actually our last Science 10 lesson as well, so you can get excited about that. So force and work, make sure you have your formula sheet out because we've got to use a couple different formulas today. So the first one for force is going to be force equals mass times acceleration. So F equals ma, and I am going to add to this. I'm going to add vector arrows over force and acceleration because force is going to be a vector. Force has direction. So the force that you're applying to, say, the ground when you walk on it would be directed towards the ground. Acceleration, also a vector, also has direction, and mass, not a vector, but when we multiply those two together, we're going to get a vector for force. So an object moves if an unbalanced force acts upon it. So I can lean against the wall right now and put a force on the wall, but the wall's not going to move because it's putting a force back on my hand. Until that force is unbalanced, that's when it's going to move. So there's enough friction between the wall and the ground for it not to move. But if I put the same force on, say, the desk that's in my classroom, it's going to move across the floor because the friction between the floor and the desk is much smaller. So I'm able to apply an unbalanced force and move that object across the floor. So it's any push or pull on an object. It can come from gravity, it can come from literally pushing something or pulling something. Forces come from a lot of different places. And then the units for force are newtons, so named after a famous old dead scientist guy, Newton, who sat under an apple tree, got bonked on the head, and is credited with discovering gravity. The other thing we're going to look at today is work. And work is when you take a force and you multiply by a distance. And the big thing here is that the force has to be in the same direction that the object moves. So the best example I have of this is when you're lifting a box. So say you're moving something heavy, you lift it, you're applying a force on the bottom of the box. So the force is up, and the only time you're doing work is when you lift it up as well. If I was to hold a really heavy box and walk across the classroom, since my force is up, but my distance is across the room, those aren't the same direction, I'm actually not doing any work at all in the scientific definition of work. So you might work up a sweat and get really exhausted carrying heavy boxes across the room, but you're actually not doing any work in the science term at all because your force and direction are in opposite, force and direction are not in the same direction. Now, if I take these equations and I kind of smush them together, ma can replace force. So here's the force times the distance. Work is not a vector, it's a scalar, and it's measured in joules. Another famous old dead guy. So the good thing about this last lesson that we're doing is the formulas, there's 3 of them. They're really simple. Rearranging them is really simple. It's done in one step. And so this should be a really nice way to wrap up. We're going to show our work properly like we have this entire unit. Physics is more about showing your work and less about getting the correct answer than any other unit in science. We've got a 30-kilogram kid that's accelerated 2.5 meters per second squared. What's the force acting upon the kid? So I'm going to start listing what I have. First of all, paying attention to my sig digs. I need them to be 2 at the end. I've got kilograms. That's a mass. I've got acceleration. And the question is asking for force. That's my question mark. I look on my formula sheet and I find the formula with F, A, and M. And the formula looks like this. I don't need to rearrange it because I'm looking for F. So I sub my numbers in. mass times acceleration. Going to my calculator now, 30 times 2.5, I get my force to be 75. That's 2 sig digs. And I have to write the proper units. But at your bottom of your formula sheet, you should see what the units for force are. Newtons. So that there would get you full marks on a physics question. Let's try again. This time we're given the force of 800 newtons acting on a mass of 15 kilograms. What is the acceleration? So same formula because we're working with the same 3 variables, but we want acceleration this time. Since the formula is so simple, I'm actually going to show you a little more of an advanced way to do the algebra. Let's do the algebra first without the numbers being subbed in. So if I want acceleration by itself and it's timesing by mass, what would the opposite of timesing be? Dividing. What you do to one side, you do to the other side. What happens on this side where the mass is on top and bottom is it cancels. We've just rearranged this formula to say acceleration is force divided by mass. So I can use the rearranged formula and I can sub in my force. Remember, you sub your units in as well. And my mass. I can go to my calculator and I can write my answer with 2 sig digs. And I have to know the units here. Acceleration is measured in meters per second squared. So that's a little bit more advanced. If you're struggling with that, by all means, you can start with this formula, sub it in like this, divide both sides with the numbers instead of the variables, and do it like you would have done back in grade 7 or 8. But we've been doing algebra for so long, we should be able to isolate these formulas pretty simply. So I'm moving on to isolating them without numbers, which is a little more advanced. All right, 300 newtons is our force. It's moving an object a distance of 3 meters. Okay. What is the work? So different formula this time. We have force, we have distance, and we want work. This is why we list our variables, because now we're going to go to our formula sheet and we're going to look for a formula with F, D, and W. You should be able to find it as W equals F times D. We're looking for W. It's already by itself isolated, so we don't have to rearrange. We can just sub our force in, sub our distance in, multiply, and I'm getting 900. And I'm just going to write that down for the time being because I need to do 2 sig digs. So we have to write this number as scientific notation because it's 3 digits long, but I need to write it as fewer digits. So I need to write a number between 1 and 10 using the beginning numbers. That number is going to be 9.0. I need to figure out if I put the decimal right there, how many do I have to move it to get it where it actually lives? 1, 2. That's your exponent, and work is measured in joules. There's your final answer. If you're really struggling with scientific notation, you should just write the 900 joules, just understanding that you're going to lose 0.5 every time you do that. So it's really a skill that you must know to move on to Physics 20. If you're going to Science 20, it's still very important, but you'll practice it more, you'll have more time. If you're moving on to Physics 20 and you don't know how to work with scientific notation, you'll have a very, very difficult time in that course. If you're really getting this stuff, why don't you pause the video and try this one on your own and see if you can write your work so it looks similar to mine. So I've got a force of 250 newtons that moves an object. The work done is 1,000 joules. How far did it move? Force, 250. Work, 1,000. How far is distance? W, F, and D are in this formula. I want D by itself. It's currently multiplying by F, so I'm going to do the opposite, which is divide. The F's will cancel top and bottom, and D will be by itself, and I need to divide W and F. Here's my new formula. Sub into it, W on top, F on the bottom, 1,000 divided by 250, that's going to be 4, and your calculator is just going to tell you 4 without any decimals to it, but we need to do 3 sig digs. So we're going to have to add some 0.00s so that it's 3 sig digs. Okay, what is distance measured in? Meters. So any question in physics, probably at least 2 to 3 marks. Have you listed your variables? Have you picked your equation and rearranged it if necessary? Have you subbed your work in with units? This part is very important. And you have your answer written with sig digs and units. All of those things we check when we look at your physics work. So last slide here just talks about the connection between work and energy. So for work to be done in science using the scientific definition of work, a force must be applied and then the object has to move in the direction of the force. So if the force is up, the object has to move up. If the force is left, the object has to move left. If the force is up and the object moves left, since those are not the same direction, there's no work done on the object. And one last definition of work is another way of thinking of it is change in energy. That's why your work, joules, has the same unit as your kinetic energy and your potential energy, because work is just a way of studying energy. They're essentially the same thing. So that wraps up the physics unit. You have one last practice worksheet and a Google form assessment that will be emailed to you, and then you'll be done Science 10. If you have any questions, please email me. If you're uncertain about whether you registered for the right courses and you'd like to talk to me about that, let me know as well and we can figure out that. Thanks, guys.